I just wanted to say a couple of things about the if-else chains because I've looked at a couple of the things that have been coming in from students on the selection structures assignment. And I see this every semester, so this semester I'm definitely going to talk about it. Let me share my screen here. Okay, so here's a program where you're asked to enter the temperature in your room in degrees Fahrenheit. By the way, is the text a bit large enough or do you need it larger? Okay, and we read the temperature. If the temperature, now this is done with separate if statements. The temperature is less than 55, you must be freezing. Next if statement, if it's greater than or equal to 55 and less than or equal to 65, it's chilly. So I have 1, 2, 3, 4, 5 different statements, if statements. And there's nothing wrong with this. This is going to work. Oh, by the way, for those of you who are wondering, what's this \U00B0? And we're going to talk about characters and strings later today. And it turns out that's the degree symbol. Let me compile this. And so the temperature is, let's say, 74 degrees. Or it seems to work okay. Now, the problem here is that I'm doing a lot more testing than I need to do. Because I'm doing things that are really, this is really a good place for an if-else chain. Let's do that. Let's make this an else-if chain. The problem with the one I had before is that it's always doing 5 tests. In fact, let's go back to the way this was here. If the temperature is, let's say, 52 degrees, it does this test. Then it will do this next test. Even though we know what the temperature already is, it's still going to do this test and get a false. Then it'll do this test and get a false. And then this one and get a false, and so on. By making this an else-if chain, and then this last one becomes an else, we no longer need to ask as many questions. If the person says it's 52 degrees, this is true. We do this and we skip everything afterwards because this else and everything depending on it is no longer needed. Do you see the advantage already? In fact, let's recompile that. And let's rerun it. 74, 51. Now, here's the interesting part. Because I have made this an if-else-if chain, I no longer need to do as many tests. When I had them as separate if statements, I had to do a lot of testing. Okay, let's try this. If somebody wants to activate their microphone, and I'll ask them a question. So whoever's activating their microphone, okay. Question, in your room, is it less than 55 degrees? So somebody turn on their microphone and answer.
No.
Okay, good. Is it greater than or equal to 55 degrees?
Yes.
Now, I didn't need to ask that second question, did I? And in fact, you're probably saying, oh, boy, that's sort of weird for him to ask because I already told him it wasn't less than 55, so it must be greater than or equal, correct?
Yeah.
Okay, that's the point that's going on here. Because when we had separate if statements, it was like 5 different people coming in and asking the question. The next person who asked the question doesn't remember what the answer was from the last person. So they have to do the thing, well, is it greater than 55 and less than 65? When I have an if-else chain, I remember what the last answer was. I don't need to ask if it's greater than or equal to 55. I already know that. If you said no to less than 55, it must be greater than or equal to 55. Otherwise, I wouldn't be asking my next question. Similarly, if you say, it's 68 degrees. Is that less than 55? No. Well, is that less than equal to 65? No. Then I know it must be greater than or equal to 65, and I don't have to ask this question. Similarly, I don't have to ask this question either. The only way I'm going to ever ask this question about less than 85 was if I got no answers to this one, and this one. And this should be a less than, not a less than or equal. Yeah. Do you see the difference here? Now, is there anything wrong with doing the compound condition? Is there anything wrong with saying temperature greater than or equal to 55 and temperature less than 65? No, it'll still work. It'll work fine. It's just that you're doing a lot of extra testing that you don't need to do. And this is also a little bit more readable. This only works when I have an else if chain. When I have an else if chain, I am taking advantage that I know the answer to the previous condition. So let's go and recompile this. And run it. And if it's 80 degrees, that's a bit warm. If it's 52 degrees, and so on, everything continues to work. So this is the sort of thing that I am suggesting that y'all pay attention to when you're doing an if-else chain. If I do something, in fact, let me save this under a totally different name. Let's call it bad room temperature on Java. Remember, if it's not an if-else chain, then I can't depend upon what the last answer was. And this is going to be a disaster. Let's say I say it's 62 degrees. Is that less than 55? No. Is 62 less than 65? Yes, it'll print that's a bit chilly. Now, completely new if statement. Is 62 less than 75? Yes, it'll print this. Brand new statement. Is 62 less than 85? Because I got rid of the else, I no longer have any memory, so to speak, of what came before. And I have to rename my class to match. Try that again. And now if I try and run that, and I say it's 63 degrees, I get more output than I wanted. That's why when the way I had it the very first time, I needed to have the compound condition because they were 5 completely different statements. The else if chain saves me a lot of trouble. So I want you to keep that in mind when you're doing the shipping program for Java. Any questions on that at the moment? Okay, hearing no objections, let's continue onwards to chapter 4. Also, let me close that dialogue, which doesn't help me. Okay, unfortunately, most of chapter 4 is going to be a laundry list of methods. There is something called the math class, which contains all your most used and most popular mathematical formulas. It is automatically imported into your programs. You do not have to say import java.math.star. It's automatically there for you. We have trigonometric functions like sine, cosine, and tangent. but there's a thing you got to be careful for. Everybody thinks, well, okay, sine of 30 degrees is 0.5. Okay, this is one of the things that people tend to memorize. And so you say, oh, great, what's the math dot sine of 30? And the answer comes back, that's not 1/2. The reason that didn't come out the way we wanted to is because sine, cosine, and tangent take their argument in radians, not in degrees. That means we have to figure out what 30 degrees is in radians. And so that would be 30 times math dot pi divided by 180. Because 180 degrees is pi radians. And now it comes out to 1/2. It doesn't come out to exactly 1/2 because, again, there's a certain amount of accuracy that the computer can have. But this is close enough for anything we want to do, unless we're running a nuclear reactor or sending a rocket to Mars, neither of which we're going to be doing this semester. There's an easier way to convert from radians to degrees and back. I can say math dot sine of math dot 2 radians 30. If I get something like the arc cosine, let's say I want arc sine, excuse me, math dot ASIN is arc sine of 0.5. That gives me the angle in radians. Oh, no problem. Hi, Jason. I was just going over some stuff with the if statement, but I'm recording this, so you'll be able to watch it later. I can say math dot 2 degrees of math dot arc sine of 1/2. And if I could spell the word degrees properly, it would really work better. Let's try that again. 2 degrees of math dot arc sine of 0.5. And it comes out to 30 degrees. So very important, remembering that you've got 2 radians and 2 degrees, and sine, cosine, and tangent take radians as their argument. Arc cosine, and that would be math dot a sine, math dot arc cosine, and math dot a tangent return radians as a result. There's the exponential function, math dot exp 1, which is the easiest one to show you. Essentially math dot exp of 3, that's the same as e to the 3rd power. There is, by the way, just as we have math dot pi, because it's a constant, remember those finals? Okay, they're by convention, we always use uppercase. There's also math dot capital E, which is the base of natural logarithms. There's math dot log 10, which is log to the base 10. And we've already, and there's the natural log, math dot log of, let's say, 20. That's log to the base e. And we've already seen math dot pow. For example, let's say 3.0 to the 4.0 power. 1. And we can take the square root by raising something to the 1/2 power, or we can use the built-in square root function, abbreviated as SQRT. Other fun stuff in the math object, class rather. The ceiling function. This gives you the next integer that's larger than the number you gave it. So math.ceiling of 3.1 is also going to be 4. Math.ceiling of negative 3.1 will be negative 3 because that's the first integer that's greater than negative 3.1. It returns it, by the way, as a double. Along with ceiling, there's the floor function. Math.floor of 3.6 gives me 3. Same there. And floor of negative 3.1 will give me negative 4. It's the first integer that's less than or equal to that. Oh, what happens if I try something like this, by the way? 3.0. Answer? It gives me 3.0. There's also round to integer. Math.rint of 3.1 gives me 3. Math.rint of 3.7 gives me 4.0. All of these are returning doubles, by the way. Now, what happens if I say math.rint of 3.5? I get 4. Math.rint of 4.5 also gives me 4. When something is right in the middle between two numbers, it always rounds to the nearest even number. The reason we do that in math is because half the time we'll be rounding down, half the time we'll be rounding up, and it'll average out. Then there is also math.round. And that returns a long, by the way. Okay. All of these other ones, ceiling, floor, and rint, all return doubles. Math.round returns a long integer. In fact, math.round of, let me make that a comment. Math.round of x is the same as long math.floor of x. Technically, that's what it's really doing. It adds 1/2, takes the floor of that, and then gives it back to you as a long. How exciting. Math.max will give you the maximum of 2 numbers. It also works with integers. If I say 3 and -2, it'll give me back that as an integer. So you can either give it doubles or integers, and it'll work great. Similarly, math.min, 3 -2, gives you the minimum of 2 numbers. And absolute value and absolute value of 8.1. Okay, again, it helps if you type correctly. So those are your main math methods. Now, the next question is, how do I know all this? Well, first of all, it's in the book. But what happens if you don't have the book available? How can you figure out what things are and aren't available to you in these classes? And the answer is, let's go to, for Java, since most of you are probably using 14, we can say Java 14 API, which is the Application Programmer Interface. And let's see where that would be here. Any one of these would probably do. Let's go to this and see what we've got here. Okay, and I can do a search for math. Let me move this up a little bit. Let's try that again here. And there's java.lang.math. I don't know if I've shown you this before. I may have shown you the API before, but it doesn't hurt to do it again. And it tells you what all the possible operations are. So here's absolute, which can take a double or a float or an int or a long. Arc cosine. And some of these you're probably not going to need, but they're all there. Oh, atan2 is incredibly useful. In fact, atan2 is much more useful than arctangent. I'm going to tell you right now. If you ever have some rectangular coordinates and you need to figure out what the angle is from that point to the origin, man, this is exactly the method that you need. So I really love ATAN2. Whenever I'm doing computer graphics, I need this method more than just about any others. But this gives you everything. More, again, this tells you more about the math class than you would ever want to know. Now, if I want a more complete explanation, this tells me literally everything. It says, okay, what happens if the first argument is positive 0 and the second argument is positive? Then the result is positive 0, negative 0, and there's a whole bunch of stuff. So again, this is the word direct from the source. So if you're ever wondering, well, what's available in a certain class that's built into Java, this is how you find out. If I ever wanted to find out what's available from Scanner, I would go there and I would have a list of all the constructors and all the methods that I can have. Huh. I'm sorry, I'm just looking at one of these. I had never seen this one before. This is pretty cool. I'm going to have to look that up later on. Okay. The website is, the way I got to it was I did a search for Java 14 API. And then I took the first link there. And in fact, what I will do here is I will paste this into the chat. There we go. And somebody remind me to, should I make an announcement, put this in an announcement or something for y'all? Okay, let's just do that real quick here. And let's call this Java API. If you want to know absolutely everything about how a certain there we go. And there's this joke about the kid who writes a thank you note to his aunt and says, "Dear Aunt Martha, thank you for the book about elephants. It told me more about elephants than I wanted to know." That's sort of what we've got here. This will tell you more about each class than you wanted to know. And some of it is very, very highly technical, but it's all there. So that's how you can find out what's available in the math class. That having been said, in the files somewhere here, let's see if I can find it here. We have example files for today. Should be, don't tell, this is interesting. Okay, I'm going to have to upload them. Sorry about this. This will take me a couple of seconds here. Let's make a new folder for 2020-06-22. Example files, 622. And let's go here and grab as well. Okay, here's one called greatcircle.java. And this will give you the great circle distance between 2 points on the Earth, if you know their latitude and longitude. So you can now, so this is, so it's mini lab time for the next 10 or 15 minutes. user is going to enter the latitude and longitude of 2 points on the Earth measured in degrees. You're going to have to convert to radians at some point. That's a hint. And then you take r times the sine of the latitude. Well, okay. Hold on. Let me open up the file here. It'll be easier. It'll be easier if I open it up from a correct place. Hold on a second here. So it's r times the arc cosine of sine of latitude 1 times sine latitude 2, this whole formula here. And r is the radius of the Earth. I strongly suggest you make that a constant, a final double r, which would be a capital R in this case. And here's some latitudes and longitudes you can use. And here's someplace where you can check to see if your answers are correct. And I've set up the business with the input for you already so that you don't have to write all that junk. So take about the next 10 or 15 minutes to work on that. And you'll be using the math class to do that. I'll put here. And again, this thing here is the degree sign. Well, let me move up here a little bit so you can see the formula. Well, you can see the formula yourselves when you download the file. Okay, that should probably give you sufficient time to figure out what's going on. And let me open up my solution file here. And since this is a final, I forgot to make it let's call it radius, which is a much better name. And here I'll call it radius. And in fact, let's comment radius. Here's what I did to convert everything to radians. What I did was I took the current latitude, which is in degrees, convert to radians, and then put it back into the same variable. I decided that would be a little bit easier for me to do than creating a whole new set of variables. If you created a whole new set of variables for radians, that's fine. It would still work out great. And you'll notice instead of trying to put it on one line as one gigantic long formula, I took the formula and broke it across several lines. And then the question is whether the plus sign belongs here or on the next line, and it's a judgment call. but broken up this way, it's fairly readable. I'm not sure if this works in Genie or not. Yes, it does. One thing that, by the way, is very useful is that when you put the cursor next to a parenthesis, notice this one's blue, the corresponding, the closing parenthesis is also highlighted for you. And the same thing happens, in fact, for braces. So you can tell where braces begin and end. You may have noticed this before. If you hadn't noticed it before, it will. You can use this to your advantage. So, any questions about the math class? Okay, then let's move on to something that's a little bit different. In fact, dramatically, well, it's different and it isn't. Let's move on to characters. And I'm not talking about strings. Those are the ones in double quotes. What I'm talking about is characters which are in single quotes. So for example, the letter A is in single quotes as a character. If I try and put 2 in single quotes, it'll tell me, no, you can't do that because single quotes means only one character is all you can do. Now it turns out that character values happen to be represented as integers, 16-bit integers. For example, if I say, what's the integer of 0? Turns out that's 48. And integer 9 is 57. Again, this is the ASCII code. This is the translation of a single character into some numeric value. Let's represent capital A, should be 65. And this also works for things in Unicode. So if I want tilde n, happens to be number 241. As the book tells you, 0 through 9 is the same as 48 through 57. Capital A through capital Z has a numeric value of 65 through 90. And lowercase a to lowercase z is in the range 97 to 122. And this brings up a question. Namely, let's say somewhere in here, let's say I have a character variable. And the way you have a character variable, you have char is the name instead of int or bool. Char ch becomes capital A. Instead of saying, I could do this. I could say if ch greater than or equal to 48 and ch less than or equal to 57, then I can say, in fact, I may as well write this. Okay. As long as I'm starting a program, I might as well go for the whole thing. What the hell? Oh, great. Let's go here and open this. And let's call this. Let me move this junk here. Otherwise, if ch greater than or equal to 65 and character less than or equal to 90, okay. I guess I should be consistent about how I write this, shouldn't I? There we go. I believe this is the way the book tends to do it. And let's see if I've got any typing errors here. Okay, good. And sure enough, capital A is an uppercase letter. If I put in a square bracket, and rerun it, I cannot classify this. Now, instead of having to change this, I'd like to be able to read a character one at a time. Here's a question: is how can you do that? Let's try this. System.out.print, enter a character. And let's say character ch equals input.nextchar. Is there such a thing? That's my first question. I could look it up in the API. This would be a good thing to look up. But instead of doing this, I'm just going to let the compiler tell me because I'm semi-lazy this morning. And nope, there's no such thing as next char. How about next character? Maybe that's the way it's spelled. Answer. Nope, you can't do that. So here's what you're going to have to do. You're going to have to say string s equals input.nextLine. S is a terrible name. Let's call it input string. And then you're going to say input string dot character at and give the position that it's at. Let's see if that works any better. Perfect. Now if I say character test and I enter a character of lowercase x, that's a lowercase letter. If I enter 5, this is a digit. Okay. I'll talk about this char at in a couple of minutes here. However, this is not a good way to do it. Instead of having to depend on what the numeric equivalents are, which nobody remembers anyway, use the single quotes and things will be a lot better. This is a much better way to write it. So I say, now there are weird things that you can do because characters are and integers are the same. For example, if I say I can add a plus 3, and that will give me 68. Why? Because a has the value 65. I would have, if I wanted it as a character, I'd have to do a cast to take the integer result and convert it back to a character. This gets really, really ugly. So you can do addition with integers and characters because they share a common basis, but I don't recommend it because it tends to lead to really ugly code. If you do have to do something crazy like this, make sure you comment it. Other things that are useful to know about characters are something called escape characters. We've already seen one of them, \n, which is the new line. There's another one called \t, which is the tab character. Do not use this in place of spaces. Okay, if you need to space something out exactly, then use the space bar, which is a space. Now here's a question. What if I wanted, in fact, let's talk about strings. You could do something like this with emojis too. Yes, you probably could. You could, knowing where the emojis are in Unicode is a very interesting task indeed. I've never done much with Java and emojis. I'm gonna have to look that up at some point. Yeah. Okay. you need two special escape sequences inside strings. For example, what if I want to do something like this? System.out.println. Mrs. Jones said hello to us. I've got a new line there. Well, I don't need the new line, hello, because I'm already doing println, hello. This is going to cause an enormous problem if I try and do this. In fact, let's copy this and paste it into the shell. And you'll see that when it got to there, it's expecting a closing parenthesis. Why? Because this quote mark closes off that quote mark. And now all of a sudden, I've got the word hello in the middle of nowhere because it thinks it's not inside the string. We need some way to tell Java, no, 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 don't close off this string. I really want you to put a double quote in the output. And the way we do that is by putting a backslash here. We're going to need one here as well. Yeah, I do want to save this actually. Today is the 22nd. Let's go on that. I take this. And now it works correctly. There's one other thing that I need to do. What happens if I want to say something like this? Do not confuse slash with backslash. They are different. Let's see what happens if I try and run that. Let's copy this and paste it into the shell. It says illegal escape character. Backslash says, hey, I'm introducing one of these special escapes, but backslash space doesn't mean anything. Okay, I'll answer your question in a moment, Najiha. If I wanted to get a true backslash, I'd put two of them in a row, saying, no, 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 don't use this backslash as something special. Make it non-special. Essentially, in fact, that is what backslash does. It takes something that's not special, like N, which is just a plain old letter, and says, no, make it special. Here, quote marks are very special inside of Java. Putting a backslash before something special says, no, don't make it special, make it ordinary. And now if I take this, oops, and pop it in there. Sure enough, okay, now the question is, what happens if I say system.out.println of Mrs. Jones said plus hello plus to us? In fact, I'm going to need blanks in here to separate the parts. Well, let's see what happens. Remember, these quote marks here are not inside of a string. They form the string. So I still don't get what I want. Oh, this is ugly. This is all I'll get out. That would work. The only way to get a quote mark, a double quote emitted as your output is to backslash escape it. And this is just a really weird way of doing it to begin with. And oh, then of course there's one that I just forgot. It's the backslash U. Yeah, hello. How about putting it in single quotes? And there's the degree symbol. And let's just see what happens if I say, oh, now, whenever you see something that looks like this empty box, what that means is that it's something that's not, that either it's not in your font or there's nothing for it in Unicode. How about A01? Nah. And that's, oh, wow, how weird is that? Wow, that's really cool. It looks like it's a little diacritical character. Ooh, cool stuff. Okay. So those are your escape sequences. Now, beware about the plus sign. Remember when I had a string, A plus 3, that told, say, okay, because it's a character, it takes it as its integer counterpart and gives me back a 68. If I say capital A as a string and add 3, what it'll do is it'll convert the 3 to a string and give me A3. So strings and characters really work different with respect to plus sign. We have this business here. It turns out there are some other things that you can do to make these tests a little bit easier. Namely, I can say character.isDigit. There's character.isLetter. How about spelling it right? Character dot, man, I'm having trouble typing today. Okay, is lowercase x. Character dot is uppercase of lowercase x. The nice thing about these is methods, like isDigit or isLetter, is that they also work properly for Unicode. So I say dot isLetter. Hold on. That comes out true. Even though it turns out remember that when we did the, it's not in the range for capital or lowercase regular letters, but Enye, it turns out, is a letter. So it will react to those properly. I was talking about strings. Let's have a string str equals. The reason I use this word playground, by the way, is because there are no repeated letters in it, and that makes it easy to figure out what's going on. Turns out that the characters inside of a string, you can think of a string as a bunch of characters all put together. The first character in a string is at position number 0. So if I say string, and this is a method that belongs to the string class, char at 0 will give me the letter P. String.char at 1 gives me the letter L. String.char at 9 gives me the D. There are 10 characters in the word playground. They're numbered 0 through 9. If I try and get the character at position 10, boom, I get the string index out of bounds exception, because there is no index number 10 into that string. Okay, what about -1? Oh, yeah. There's a Python programmer asking this, because in Python, if you say string.char at -1, it will give you the D. It'll count backwards from the end. Java, don't go for that kind of stuff. So it says, no, you can't give me negative numbers. Too bad. Well, as long as we're talking about things, by the way, these strings, I can say string.length. This is a method that takes no arguments, and it'll tell me how long the string is. I can say string dot to uppercase. Now, this always gives me back a new string. If I look at what's in string, it's unchanged. All of these string methods give you back some completely new string. They never, ever, ever, ever change the original. Let's see what I can do here. There's also string dot concat. And that's the same as plus sign, really. So you may either use the concat method if you want to, but most people will use plus sign to add strings together. Okay, this is a good place to stop. And what happens if I would? I'm throwing a lot of things together as sort of again, this is sort of a laundry list. Remember the math.random business that I had? I could say here, for example, let's make a character out of the letter A plus 26 times math.random. I better make this an integer here. And that will give me a random uppercase character. Pretty cool, huh? Now the question is, why am I doing this? The answer is because here's another quick lab for you all to do. And this one is create postal code.java. Canadian postal codes have the formatter letter, digit, space, digit, letter, digit. So this is a valid Canadian postal code, X3B4M9. And whether it's a real one, I have no idea. Okay. And letters are always going to be uppercase. You can use the %C format specifier to do characters. Let me go back in here. For example, string.out.form, let's see. So when you want to put a character out, use the %C specifier. What was the zip code you used again? The zip code is, again, it's the letter, a digit, and a letter. So here's another one. Let's say T, letter, digit, letter, space, digit, letter, digit. And that would be valid as well. But you're going to create one randomly. So the idea is that your program, it doesn't need any input from the user. Every time you run it, really, okay, I had no idea. Okay. How did you find that out, Andrew? I'm just curious to know. And then in the chat room, somebody's saying, what's the zip code you used again? And X is reserved for the Northwest Territories and X3B is not currently used. Okay, Wikipedia has that. Wait, what's Nunavut? Is Nunavut, I thought that was the Northwest Territories. I'm getting confused on that. Unfortunately, I'm geographically challenged. If you ask me where Alviso is, I wouldn't even know that. So. Yeah, okay, that's right. Ah, okay, that's why I was getting them confused. Thank you. Nunavut was cut out of the Northwest Territories. Got it. So at any rate, take the next few minutes to do that. And if you feel really ambitious, the other thing you can do is write a program that will validate a postal code. And you may need to know a little bit more, but if you've read the book, you'll know how to do this part of it. We know how to convert to uppercase, and then check to see that the string that they enter is in the correct format. And again, I've written part of the code here for you so that you don't have to write all the boilerplate yourself. So work on either one of those or both. The program to either create a postal code at random or to validate one that the user puts in. In fact, I'll work through this one with you maybe a little bit later. So start on either one or both of them, and let's use the next 10 or so minutes for that. And let me stop recording again. And by the way, on Mondays, one of the people in here is Armand, and he's the tutor. And so if you have questions, you can do a private message to him in the chat if you want to. So he's around to assist us on Mondays. Okay. Would y'all like me to show the solution for this one for creating the postal code real quick? Okay. Here's what I did. I said, let's have a character called letter number 1, which is going to be a character, which is a capital A plus the integer part of math.random times 26. Let me put some parentheses there to do that. I'm going to need 3 letters and 3 digits. And so in this case, copy and paste is going to be my friend. Let's call this L2, and let's call it letter 1. Letter 2, and letter 3. Then the next thing I need is a digit. So digit 1 is going to be the character equivalent of the character 0 plus int math.random times 26. No, hello, 9. Let's try that. There aren't 26 digits. There's only 9. And also we want random, not radnum. Normally I don't put extra spaces, but I think I want to make this look nicer. So letter 2, digit 2, and digit 3. That. Then we'll do a system.out.format your random Canadian postal code is character, 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 space, character, 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 period. And then we fill in the blanks with letter 1, digit 1, letter 2, digit 2, letter 3, and digit 3. And let's Java C create postal code. And congratulations, I have a problem here. Oh, yes. I didn't modify it. Copy and paste isn't my friend. I lied. Okay. Again here. Yes. Remember, I need to create a character between A and Z. There's 26 letters in the alphabet. So I'm just taking a random number between 0 and 25 and adding that to A. If it's 0, A plus 0 is A. If it's 1, A plus 1 is B. All A plus 25, 25 letters past A is the letter Z. Or because this is Canadian, the letter Z. Similarly, I have the digit 0, and this would give me 8.9999. 8 digits past 0 is the letter 9. No? Does it need to be 27? Okay, hold on. Let me think out loud here. 0 plus 0 gives me 0. 0 plus 1. You know what? I think you're right. Okay, I lied. Okay. So this definitely has to be 10. And I think I may need 27 then in this case. Let's try putting it as 27 and see what the heck happens. Okay. No, there's still 26 letters in the alphabet. Never mind. Okay. But there are 10 digits. Yeah, you're right on that. Let's. And there are my random postal codes. Now, one thing, by the way, you may have noticed is that every time I want a new postal code, I have to go and run the program again, which is sort of irritating. How many different substitution symbols are there, like %C, %F, and so on? Oi, I don't remember, but I have it here someplace. Let's go back to our pages here. And formatting output. You can see the exact specification for format strings at this URL. Yeah. Brother. So I have decimal integer, float, new line, date and time conversion. Oh, brother. Okay, we don't get me started on that. And then you have the with, positive or negative. So actually, there aren't that many of them. Yeah. And this is how you know which one you want to use. The one you use is dependent upon the data type that you have. Yeah, that's nice. Decimal format class. Boy, this does not give all of them. I'm surprised. Okay, let's go back to our API. Where was that here? Shoot. Let's go back to here. I may have to update that. And, it turns out there's a synonym, which is probably going to be better here. Great. Let's see here. Well, this is interesting. Okay, let's try Java string format specifiers. Formatter. Okay, here they are. There we go. So B for Boolean, hexadecimal. Oh, cool. String, character, decimal, octal, hexadecimal, decimal number in scientific notation, decimal number, general format. Oh, hexadecimal floating point. Wow, that's sort of weird. Date and time and percent and line separator. So there we go. That's where they really are. I'm just curious to see if I do a 14. Okay, not found. I'm going to copy this and just paste this in here someplace so that I can remember it later. Everybody okay on this so far then? Now, in order to do the validator code, there's something that we're going to have to do, because one of the things I wanted to do is trim the leading, trailing blanks and convert to uppercase. I've already talked about this. Remember, our string was playground, and I can say string.to uppercase. The question is, what happens if I have, let's say here, string 2 is sorry about that. Let's try that again here. What if I want to get rid of those blanks at the beginning and end? I can say string 3 is string2.trim. And you'll notice that gets rid of the beginning and ending blanks, but if there's a lot of blanks in the middle, it will not get rid of them. So we need to know about that. And as long as I'm talking about string methods, let's talk about some other thing. Let's say I say string3 dot starts with the word this. That's true. String3 dot starts with that. Is false. String3 dot ends with test. String3 dot ends with best will be false. So I can tell if something's at the beginning or end of the string. String3 dot contains, does it contain the letter A anywhere in it? The answer is true. Answer is false. There's no Q anywhere in there. And I can say, let's go back to string3. So I can say string3 dot contains is true. Now, what if I want to know exactly where it is? I can say string3 dot index of is, and it'll give me the starting position of the letters IS, the first occurrence. And that's true. Remember, we begin at 0. T is at 0, H is at position 1, and the word is begins at position number 2. See, I just want to change. Okay, I'm recording. I just want to make sure I was still recording here. So far, so good on this. So index of gives me a position where something is. I can say index of, what happens if I do something like was that is not inside the string? It returns me a -1, meaning it wasn't anywhere in the string. I can also find the last index of is. The last index of, the last time the word is occurs in string 3 is at position 0, 1, 2, 3, 4, 5. Blanks count. This blank is at position number 4. T is at 0, H is at 1, I is at 2, S is at 3, space is at 4, and this last word is begins at position number 5. Let's call this hold on a second here. Good question. Why did was come out to -1? Let's look at string 3. The word was, the letters WAS don't appear anywhere inside that string. That's why string3 dot index of was comes back as -1. It's looking for those 3 letters in that order, not for a letter W anywhere, a letter A anywhere, or a letter S anywhere. It's looking for that sequence somewhere inside the string. That's why was, and in fact, string3 dot last index of will also return a -1 because there isn't one anywhere inside that string. Okay, yeah, let's go back here. Our string was playground. You can also take parts of a string. For example, I can say string last part is str. Yes, the index of is position based. Contains gives you a true or false. Contains just say, yeah, it's in there, or no, it isn't. If I say string.contains was false, contains is, sorry, string 3 contains is, it says true, but we don't know where it was. Sometimes it's just good enough to know that, yeah, it's somewhere in there. But if we want to know exactly where it was, then we need to know the index of, which gives us the starting position. And then we can use this with what's called substring. So let's look at string, and I can say string last part is going to be string dot substring, and I can say where is the beginning position. If I say 4, that says start at position 4 and go all the way to the end. And that gives me the word ground. I can say string middle part is string dot substring, starting at 4 and ending at position up to but not including 8. Sorry about that. I have to spell it all the way out. This is the problem with learning a lot of languages. In some languages, it's called substr, and in other languages, it's called substring. And I got them confused. And that gives me the starting position up to but not including an ending position. How come 4 is included? The starting point is included. It's like in almost everything that you see in Java, it includes the starting point but does not include the ending point. And when we start learning about loops, it's going to fit just right into it. So the starting point is always, it's an open interval. It's just like math.random. If I say math.random, it starts at 0, including 0, up to but not including 1. And that's just the way the language design has grown, I guess, is all I can tell you. So that's substring. And one other thing that I want to talk about strings is doing conversions. When we want to say convert a string into a number, let's say we get some input from a user and we need to convert it somehow, or if we've extracted this. Oh, okay, here's a good example. This is an example. Okay, this may actually work. Let's put this here. Oh, I'm sorry. I keep forgetting to do my declarations here. What I want to do is I want to isolate the 374.28. What I'm going to do is I'm going to say integer space position is going to be string 4 dot index of blank. Where is the blank inside of string 4? It's at position 6. Now what I'm going to do is I'm going to say string money string is going to be string 4 dot substring starting at the space position plus 1 all the way to the end. Now my money string is 374.28. I need to convert that to a double. And the way I do that is I say double dot parse double, let's put it double, is going to be double dot parse. And that converts the string into a double. You need to be able to do these conversions when there are instances that you can't use a next int or a next double. If you have some string that you've read from a database or from some file somewhere, and you have to extract a number from it, that's where you're going to use these things. You have also integer.parseInt of and that will return a true integer. It'll convert a string to integer. What about going the other direction? What if I have an integer and I need to create a string out of it? There's two ways to do it. Let's call this int if I say amount plus the empty string, and what that will do is it will convert the amount, which is an integer, to a string so that it can use the plus sign to append an empty string, and that'll give me that. I don't like this. The book thinks this is a wonderful thing to do. I think it's pretty ugly. What I'd rather say is string dot value of amount, and that'll do the conversion. So I can say string dot value of money, which is a double, and it'll convert it to a string for me. So you can either append an empty string, or you can append, or you can do string dot value of. You know what I'm going to do? I'm going to grab all this stuff here. I'm going to copy it, and I'm going to make a new file that contains all that stuff. And let's do this, save as. Substring and numeric conversion.txt. There we go. Everybody okay with this so far? So being able to manipulate strings is really, really powerful stuff. This is excellent. Now we're coming along really great here. Why don't I go and show you the solution to this? Well, let's put this to a quick vote. How many people would like to be able to work this on their own for about 10 minutes and then see me give the solution? Or do you want me to just go straight for the solution? Okay, I've got one vote for work 10 minutes. And why do we use parse? Okay, because in this instance here, let's go back to this one here. Sometimes I may get some input from the user that's not a pure number. I might have something like this. Yeah, this is something. If I have a file, for example, and my file looks like things like a and I've got the populations in there. Okay. So let's say I'm reading these things from the file. When I read it, I have to read this whole string all at once. And then I need to extract the number from it to put that into some calculation. And that's where I'm going to take the string and parse it into a number to convert it into an actual number so I can do arithmetic with it. So that's why we use parse. Okay, so next 10 minutes we'll be working on the validate a postal code. We now know how to trim leading and trailing blanks. We know how to convert to uppercase. And then this is the, oh, wait a minute, I can't do that yet. There's something I totally forgot to tell you folks about. I lied. And namely, this is string comparison. This is really, really important. Let's say I have a string S1 is ABC, string S2 is DEF, and string S3 is ABC also. Yeah. If I say something like S1 is equal to S3, it turns out it's true, but that's not the correct way to do comparison. The problem with string, well, not the problem. Strings happen to be what's called a reference type, and this is detailed in the book. When you compare this S1 and S3, you're actually asking, are these in the same area of memory or not? For example, let's say I do this. Let's say I say string S4 is AB plus C. I'm just curious if this, sorry about that. Man, I'm getting my languages all mixed up here today. And now let's try S1 is equal to S4. Come out to, okay, I'm not getting it to fail the way I want it to work, unfortunately. So here we have S1, S2, and S3. To do a comparison the correct way, you say S1 dot compare to, and that will give you a 0 if S1 is equal to S3, a negative number if it's less than, and a positive number if because S2 is bigger than S1. And this is done by dictionary order, essentially, what's called lexicographic ordering. You have to be careful with this. Using characters works, you can use less than and greater than. Let's say I have here, for example, string animal1 equals okay, there's also one other thing I can use, by the way. I can say animal1 dot equals animal2. That's another way to do a quick equality comparison. Man, my typing is really bad today. And that comes out to be false. Let's go back here and say animal1. So animal1 now, let's say I say animal1 and compare it to animal2. It's negative. That means that animal1, zebra with a capital Z, yes, it does matter. Zebra with a capital Z happens to be less than ant with a lowercase a. Why? Because capital Z is 90 and lowercase a is 97. So capital zebra sorts before lowercase ant. Capitalization really does matter when you're doing a comparison. So compare to, so yeah, let me grab all of this stuff here. Let's copy that. And let's paste it in there. And where do we have to go here? String 0. There we go. Okay, now let's go for 10 minutes and working on the validating the postal code. You won't need to do comparisons at this point. If you do everything in characters, it makes it a lot easier than if you use substrings. And I'll stop recording. No. I want to pause recording. Now, the next question that I have here is, do I want to use things like character.isLetter, for example, to do something like this? And the answer is that's true, but also character.isLetter, remember, it works with Unicode. So if somebody decides to put in a postal code with an Icelandic thorn, it'll say that's also true. So the question is, do I want to allow things like that, or do I want to restrict it through truly capital A through capital Z? Gee, Armand, do you have a reading on that? Which would you prefer? It makes a difference in how I write it, believe it or not. I have one restrict it, okay? But I like Icelandic characters. No. Okay, so I've got to vote for restricting it, so we're going to do it that way. Cool, I can make this work. Okay, we have our postal code here. What I'm now going to do is trim the leading and trailing blanks and convert to uppercase. There are two ways to do this. I can say postal code becomes postal code.trim, which gets rid of the leading and trailing blanks. And then in a second step, I can say postal code.toUppercase. That's one way to do it. By the way, one of the things I'm going to do right now is I'm going to test to see that that actually works. Because what I'm going to do is going to say that it's always invalid. I don't care because I haven't finished that part of it yet. Let's do a validate postal code. Oh, it'll trim as many blanks as you have. The question was, how does it know how many characters to trim? So for example, if I run the program here and I say A3, B4, oh. Okay. There are no blanks to trim, so it doesn't do anything. If I say something like this, and a whole bunch of blanks after it, it'll just trim off as many as there are. Oh, I didn't try it with a lowercase. Let's just try something here. Excellent. So it is doing the uppercase properly. I could do it in 2 steps, or I could do it in 1 step by doing what's called a chain of function calls. I can say postal code equals postal code dot trim, and that result will go to uppercase. If this sort of freaks you out to see this, then you don't have to use it. You can do it in 2 steps. Either one of them will work. Okay, the next thing I need to do is extract all the characters that I'm going to need. I'm going to say letter 1 is going to be postal code dot character at 0. Oh, whoa. Before I do that, I just realized if you give me something that's not exactly 7 characters long, if you put in too many blanks, or if you give me something too short or too long, I can tell you right away that it's not valid. So before I even go into all of that stuff, I'm going to say if postal code dot length is exactly equal to 7, then I've got a chance of it being valid. Otherwise, forget it. I don't need an else, remember, because valid has been set to false. Oh, that reminds me. Somebody asked yesterday about if something is a default of 0, how come you have to initialize it? It turns out I was wrong on that. When you have something in a object class, and we'll talk about those much later on this summer, when you have a class property, those have default values. When you have what's called a local variable, like this Boolean, it does not have a default value. So that's why we have to initialize it. So if you wanted to pick that back up. Okay, we've got that letter 1 is postal code char at. digit 1 becomes postal code dot char at 1. And let's go here and let's letter 2 is going to be there. Then after those first 3, spacing should be postal code dot char at 3. We have the space in between the first 3 and the last 3. Then I have digit 2 is going to be at position 4. Letter 3 will be at position 5, and digit 3 had better be at position 6. Okay. Now I'm going to do this with one big honking Boolean expression. Valid is the result of evaluating this. Letter 1 greater than or equal to A, and letter 1 less than or equal to Z, and digit 1 greater than or equal to 0, and digit 1 less than or equal to 9. And do I want to, yeah, well, let's keep going on this here. Letter 2. Spacing has to be exactly equal to a single space. There's letter 1. Now I got digit 2, letter 3, letter 3. And finally, my last thing that I need to look at is digit 3. And there's no and at the end of it. So if all of those things are true, then it's valid. Otherwise, it isn't. And then I check to see whether that's a true or false. Let's go here and let's compile that. And boom. Oh yeah, hello. First of all, I didn't copy and paste properly. Yeah, well, let's think. The question was, if you set valid to false at the beginning of the program, won't it be false later no matter what? No, it won't, because here I'm setting it to false. Let's say the postal code length is exactly equal to 7. I grab all these letters. Now I'm taking this condition here. I've got a whole bunch of questions I'm asking that either could be true or false. Letter 1 could be between A and Z, and digit 1 is between 0 and 9, and letter 2 is between A and Z, and the space is where it belonged. If all of those things turn out to be true, valid will be set to true. Very important. I did not put another Boolean valid here. If I do that, then it gets screwed up for reasons of what's called scope, and I don't want to get into that now. So here, valid could get reset to true if all of this is correct. Once I'm outside of this if statement, now I can test. Either it'll still be false. What happens if I don't put Boolean valid equals false? Again, because this is what's called a local variable. Hold on. Shoot. Sorry about this. I'm getting my windows mixed up here. Java C validate. It gives me this. Local variables do not have default values. Because I've done this, I don't need to say something like this. Otherwise, valid. It wouldn't hurt to do this, but it doesn't help me either. Sometimes I put in the else because I like to have an else for every if. This one, actually, I'm okay with putting in that extra else. I don't see how many other typing errors. And now let's try to validate my postal code. And if I try something like A5C 3J7, valid. Let's try something that's not valid, A5CJ37. It's not valid. And if I try it again and say A5CJ37 without the blank, it's not valid. So there's that program. You may be wondering why I didn't use isDigit here for saying character dot, oops. So that I would avoid having to do all of this testing here with the less than and greater than business. The reason I didn't use it is it turns out that 0 through 9 are not the only digits available in Unicode. There are other alphabets that have their own way of doing numerals, and their numerals also become true for isDigit. And so I couldn't, just in the same way I couldn't use isLetter because of characters like Icelandic or whatever other alphabets you have out there. It turns out there are other digit systems and Unicode knows about them. And so I can't use those either. I have to do it the hard way here. That pretty much takes care of chapter 4. Which means that the rest of our time is available to work on. It turns out, I thought that selection structures was due today. It turns out it's due on Wednesday. So that gives you more time. How many of y'all have started on it? Has everybody gotten a start, or y'all going to start today? Which is fine if you start today. That's cool. Finished it but forgot to submit it. Okay. I'll put this in an announcement. If you submit something early and you say that you finished it, put a comment there saying it's okay to grade, and I'll grade them early if I possibly can. If you don't put in a comment saying, please grade this now, then I will leave it alone until after the due date. Some people, what they do is they write the thing and they upload it to Canvas just so that they'll have a copy of it somewhere. And it's not the one that they want graded. So when you want something graded, just put in, yeah, please grade this now. If I have extra time and you want me to look at it, put a comment saying, look at this if you have time, and I'll be glad to make comments on it. So the rest of this is going to be lab time. Armand is here to assist you and ask me pretty much anything. I'm going to stop sharing the screen. I'm going to stop recording and turn off my microphone.